Hello, let's continue our Sudoku adventure with Reapin hooks by rockratzero. So we have normal 6x6 Sudoku rules. That means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have killer cages in the grid. That's the cell surrounded by dotted lines. The digits in the cage sum to the value in the top left. So these 3 sum to 9, these 2 sum to 11, etc. We also have palindrome lines in the grid. They read the same forwards and backwards. So if I put 2, 3, 4 along here, then from this end, we need to do 2, 3, 4 as well, because it needs to read the same forwards and backwards. Ignore the red. We're just doing the example. So this reads 2, 3, 4, 4, 3, 2 this way, and it reads 2, 3, 4, 4, 3, 2 that way. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, there's a few forced cages in this grid. Like 11 has to be 5, 6. 7 has to be 1, 2, 4. That actually puts 1, 2, 4 here and 3, 5, 6 here. That puts 1, 3, 4 here. Okay, this 9 doesn't have a 3 in it, so it's actually a 4, 5 pair, because the only way to add to 9 is 3, 6, or 4, 5. And so that makes the 4 here. That's on a palindrome. That's going to copy there. The way that I didn't mention this in the rules, but the way I like to think about palindromes is just clones, right? This is a clone of this. This is a clone of this, and these two are clones. So we can actually just fill out, if we want, we can fill out these pencil marks, just transfer them. 1, 2, 4 goes there. So this can't be 3 or 5. So this is a 6. That makes that a 5 and a 3. Makes that a 4 and a 5. Nice. And this is a clone of this one. So this is 1 or 2. In fact, Sudoku does that anyway, but these are the same. Okay, what are we doing next? We have a 9 cage here. It doesn't have a 4 in it. So if a 9 cage doesn't have a 4 in it, the only way that you can add to 9 without a 1 is 2, 3, 4 in 3 cells, but it doesn't have a 4 in it. So it has to have a 1 in it, which means these are not 1s. Now the 2 and the 4, so it's either going to be 1, 2, 6, and in fact the 6 is in one of these two, or it's going to be 1, 3, 5. 1, 2, 6 or 1, 3, 5. Something I'm seeing is this 3, 5 looking up. So if this is 1, 2, 6, this cell's a 6. If it's 1, 3, 5, this cell's a 1. So this is going to end up a 1 or 6 only. I don't know if that's necessary, but I noticed it. Maybe there's something going on with these palindromes that's interesting. In general, we need 1, 2, and 6 only for this column. Oh, well, that does it then. This can't be 1, 2, 6 because this would have no value because the column can only have 1, 2, and 6 in it left. So that does mean that this is not 1, 2, 6. So this is not the 6. This is the 1. This is the 6. That's the 2. That transfers there. The 4 goes there. We get the 1 and the 1 here. This is 1, 3, 5, which we know the order of. That leaves a 2 here. Okay, that's a lot of progress. 3, 5 there means that's 3, 5. Okay. So this pair is a 2 and a 6. We know the order because the given 2 down here. That's a 5 and a 6. That's 3, 1, 2, 5, 6, 3, 1, 1, 5. And suddenly we're done. Nice. Cool puzzle, Rockrat. I enjoyed it. Nice use of the palindromes. I liked this step here where this couldn't be 1, 2, 6 because it breaks that cell. I wonder if there was a cleaner way to see that. I mean, that was pretty clean to me, but you had to have penciled this to see it. So I wonder if you thought about that differently or if you found a different way to make progress. Let me know. And of course, if you enjoyed this content, then why not leave a like, subscribe, and a kind comment below.